Okay, hello everyone. This is the lecture, the first video on the lecture bond valuation for an undergrad course in corporate finance. What type of security are we analyzing here? So we are talking about a specific security. So when a government or a firm borrows money, usually what happens is that they get the money up front, and over the life of the loan, they will only pay interest until the maturity date of the loan, where they will repay the amount of money borrowed. So if a company borrows $1,000 with a 12% annual interest, the company will make a total of $120 in interest payment in a year, and will repay the $1,000 at the end of the life of the loan. So if the maturity of the loan is 30 years, the $1,000 will be repaid after 30 years only. Governments do the same. When they borrow money, they only pay interest over the life of the loan, which is different from where you and me borrow to buy a car or to buy a house. So when we buy a car or a house, we pay capital and interest over time with a constant payment. So these would be different securities. So here when we talk about a bond, so the bond is interest only before the maturity date, and at the maturity date, the last coupon payment plus capital is repaid. So here's an example. So you may have if the bond specifies a 12% annual interest rate, this could be a single payment of $120. There could be two payments of $60 or four payments of $30, depending on when the coupon payments are made and the frequency of these coupon payments specified in the contract between the borrower and the lender that we call the bond. So this is what a $120 per year would look like. So you would have a total of 30 payments. If the bond makes semi-annual payments, like what we see at the bottom of the slide here, so there would be 60 payments of $60. So a bond is a contract that specifies the characteristics of the loan. So the face value is what is the amount to be repaid when the bond reaches its maturity date. The coupon rate is the percentage of F being paid as interest every year before the maturity date. The maturity date is the number of years before F is repaid. The number of payments per year. So I times F, that's the total annual coupon payment. So if we divide it in 4, we could make 4 payments of I times F divided by 4. So the contract specifies how many payments per year. So we will represent the bond price by P. The yield to maturity Y, that's an APR. That's the annual percentage rate that is consistent with today's bond price. So assuming this rate is constant, so assuming we use the same rate to discount all future cash flows of the bond, the yield to maturity is the annual percentage rate that gives us the correct bond price. And a zero coupon bond is a bond that does not pay any interest. So I is equal to 0. So it's a bond that only repays F at the maturity date. So the annual coupon payment is calculated as the coupon rate times F. And if there are M payments per year, so each coupon payment is IF divided by M. So the price of the bond with a maturity date in years given by capital T, and that makes M coupon payments per year, will make a total of T times M coupon payments. So in our previous example, so when we had a 30 years a 30-year bond making 2 payments per year. So that was giving us 30 times 2 coupon payments. Each coupon payment here is the annual coupon payment divided by the frequency. And the rate we need to use is the interest rate between 2 coupon payments. So the yield to maturity Y is an annual percentage rate. That is not the effective annual rate. The annual percentage rate is the sum, okay, of all the is the number of times a coupon is paid per year times the rate of interest prevailing between 2 coupon payments, which means the effective annual rate here is given by 1 plus y divided by m to the power m, as we have seen in the interest rate section. So the effective rate we should be using is based on the rate of interest prevailing between 2 coupon payments, and the rate of interest prevailing between 2 coupon payments is y divided by m, which is the rate we use to discount the face value. So we do not discount the face value by 1 plus y to the power number of years. So we need to use 1 plus the interest rate between 2 coupon payments, and this to the power total number of coupon payments. So that would be the coherent way to discount the face value. So using this method, so the face value is discounted at the same effective annual rate as each coupon payment. Good. When a bond is issued and when a bond making positive coupon payments per year is issued, usually the coupon rate is equal to the market interest rate. So usually the coupon rate is equal to the yield to maturity, which means that the price of the bond when issued is exactly equal to the face value. As time evolves, the yield to maturity will vary, but the coupon rate will remain constant. So I, the coupon rate, is a contract. So I times F will be paid to the bondholder over the entire life of the bond. But the yield to maturity, so the yield, the APR that has to be used to discount all future cash flows of the bond, will vary with market conditions, meaning that the price of the bond will evolve over time, will be sometimes above F, sometimes below F, sometimes still equal to F. But when when the money is borrowed, usually the firm borrows F, repays F at the end completely, and makes interest payments in between. So again, from this coupon here, we see that Y is an APR, okay, and the EAR in this problem is 1 plus Y divided by M to the power M. That's the effective annual rate. So here when we discount F is discounted as 1 plus the effective annual rate to the power T. What is the price of a bond making annual coupon payments of 12% over a face value of $1,000 with 1 payment per year, 30 years to maturity, and a yield to maturity of 10%? $1,188.53. So here, note that if the coupon rate is larger than the yield to maturity, then the bond price is larger than the face value. So here the bond price is $188.53, larger than $1,000. Why? Because someone buying this bond for $1,000 would realize a return of 12% over the life of the bond. And the market at this time offers 10%. So if there's one bond offering a 12% return and all other bonds with similar risk characteristics only offer 10%, all bond investors will jump on this specific bond, on the bond offering a 12% return. This will push the price of this bond up until it reaches a point where it's consistent with the rest of the market. So $1,188.53, this is the price which provides the bondholder with a return of 10% over the life of the bond, which is consistent with what other bonds with similar characteristics are offering in the market. What's the price of a bond here making semi-annual payments? So the same coupon rate, but 2 payments per year. You see that when we make the calculation first, the interest rate we use is not 10% per period, but it's 5% per period. Because here, a period is 6 months, and there are 60 periods, and the interest rate per period is 10%. So the price of the bond here is slightly higher than the price of the bond making one annual payment because the bondholder receives the money a bit faster. So in the first year, instead of receiving $120 at the end of the first year completely, the bondholder receives a first slice of $60 after 6 months and the second slice of $60 after 1 year. So there's always 1/2 of every annual coupon payment received faster than in the case with annual payments, which gives the bond a price which is higher than the price of the bond making one annual payment. What happens when the yield to maturity is 15% instead of 10%? In this case, the bond price falls below the face value. In this case, the bond price becomes $800.02, which is consistent with a 15% return for the bondholder. So again, if the price were selling for $1,000, the return to the bondholder would be 12%. But then other bonds with similar characteristics would offer a return of 15%. So nobody would buy the bond offering only 12%. So anyone wishing to sell the bond would have to reduce the price to attract buyers, and the price has to be reduced up to a point where this bond here offers a similar return, offers the same return as bonds with the same risk characteristics. Okay, so again, so this is what we have just discussed. So when the coupon rate is larger than the yield to maturity, the price is larger than the face value. When the coupon rate is equal to the yield to maturity, the price is equal to the face value. When the coupon rate is below the yield to maturity, the bond price is below the face value. And over time, the bond price has to slowly move towards F, because 1 second before the end of the life of the bond, this bond will pay F. Okay, so if we are 1 hour, if there's like a 1 day, I hold a bond and tomorrow the bond expires, paying me F. If someone wants to buy this bond from me, I won't accept anything but F. Okay, I won't accept a price below F for this bond. So slowly but surely, the bond price converges towards F. If at the same time F is repaid, there's also a coupon payment, and my bond expires tomorrow, and someone like really wants to buy it, okay, for whatever reason, well, the only price I will accept is F plus the last coupon payment, because this is what the bond will pay me tomorrow. Anything below that makes me lose money. Anything above that makes me happy, but nobody will offer me more than what the bond will pay tomorrow. Okay, finally for this first video, so what is the return to a bondholder who gets rid of the bond before its maturity? Okay, so someone buys a 30-year bond with a coupon rate of 10%, one annual coupon payment, a face value of 100, and a yield to maturity of 5%. So at the start of the year, the price of the bond is $176.86. The same bondholder sells the bond right before the first coupon payment at a price P hat 1, which is the coupon payment to be received tomorrow, like $10. $10 is 10% times 100 plus whatever will be the value of the bond, taking into account the 29 remaining coupon payments and the 29 periods before the face value will be collected. So this is the price of the bond just before a coupon payment, which is the coupon plus the price of the bond after the coupon. So the price of the bond after the coupon. So a 30-year bond, one coupon has just been made, 29 coupons left. Each coupon is $10 and face value is 100. Yield to maturity is 5, discounted over 29 periods. So that gives $85.71 for a return to the bondholder of 5%. So the return to the bondholder, if the yield to maturity does not change over time, is equal to the yield to maturity. Now, what if the bondholder sells the bond right after the coupon payment? So at the start of the year, the bondholder buys a bond $176.86. It waits the first coupon of $10, and right after receiving that first coupon, it sells the bond to the market. So when it sells the bond, when the bondholder sells the bond to the market, so there are 29 coupon payments left. The next coupon will be received 1 year from now. The face value has to be discounted over 29 periods. So the bondholder is able to sell the bond for $175.71 for a return of coupon plus price obtained when selling the bond divided by price paid at the beginning of the period, which is exactly 5%. So whatever the bondholder does with the bond, okay, selling it before a coupon or selling it after a coupon, if the yield to maturity remains constant over a year, the bondholder realizes a return equal to the yield to maturity. Okay, and here we can see that this will be the last slide of this video. It's only to show that take a bond at the start of its life. Okay, at some point in time, take a bond selling at a premium, a bond selling at par, and a bond selling at a discount. Okay, so the bond selling at a premium has a coupon rate of 6% when the yield to maturity is 4. The bond selling at par has a coupon rate of 4 when the yield to maturity is 4. And the bond selling at a premium has a coupon rate of 2 when the yield to maturity is 4. So all three bonds slowly move towards F, which is $100. And each of these bond prices go down by the amount of the coupon payment 1 second after each coupon payment. So the fall of the bond selling at a premium is larger than the fall of the bond selling at par, because here a coupon is 6. So each time a coupon payment is made, So the second after, the bond price falls by $6. Whereas for this one, each time a coupon is made, the bond price falls by $4. And for this one, the bond price falls by $2. But all these three bonds will terminate their journey at a price F. And this is the end of this first video.